All right. I just want to wrap up chapter 19 right now. The last thing I want to talk about is an aircraft moving faster than sound. So we can figure out how fast it's going if we know something about the cone that it is made. So you look at this picture and you can see this cone. It's that thing in pink there. If you look here, they're kind of showing you the cone here. So let's picture this. I'm going to say that I had an aircraft and it is flying along this line in the middle is like its path. So at one point in time, it was right there where I put that blue dot and it sent out that circle, that's its disturbance, and that went out in all directions. So you should think of it as a sphere, not a flat circle. So it sent out this disturbance that went there and it went there, and it went there. It went out in all directions, okay? So I am looking at another moment in time. So I am looking at the moment in time where the aircraft is right here at the tip of this cone. So if we know the cone it made, we know the cone, we know something about it. I know my airplane is right here, right now, and I know that at some point in the past, it was right there and it sent out that disturbance. So I know that, and that is a sound wave, that disturbance. So it's traveling at the speed of sound. So I know that in the time it took sound to go from there at the very center where it was generated to there where it is now, the aircraft went that far. So I can figure out relative to the speed of sound how fast this plane is traveling based on the speed of sound. So I'm going to do distance plane, the distance the plane traveled, divided by the distance sound traveled. Distance plane versus distance sound. So this shows you distance plane. And this shows you distance sound. Okay, so you will take out your ruler and you will measure that. And I don't have a ruler with me up here. So let's say I measured that, and it doesn't matter that you're measuring. We know the plane didn't go 7 centimeters. We know it went a lot farther than that. But this is just a scale drawing, like all those other diagrams and things that we made, okay? So I'm just going to measure both, make sure they're both in the same unit. So let's say I do that, and I get the distance the plane traveled was, say, 10 centimeters. It's probably not if we measure that. And the distance sound traveled was 2 centimeters. That means in the time it took sound to go 2 centimeters, the plane went 10. If I divide 10 by 2, I get 5. So the plane is moving 5 times faster than sound. If that is true. Moving 5 times faster than sound. All right. So if we say sound is 331 meters per second, and it depends a little bit on the temperature, not a lot. So let's say sound is 331 meters per second. 1500, 1655, 1665, wow, meters per second for the plane. So to give you some, and that is called Mach 5. So Mach is like speed of sound, 5 means 5 times it. So Mach 5. You probably heard that in films or television or something, I don't know. So, but to give you a little bit of perspective, 1,000 meters is a kilometer. Maybe you've run a 5-kilometer run before or done a walk 5 kilometers. It's about 3 miles. So I am telling you that in less than 3 seconds, it's doing a 5K. It's doing a 5-kilometer run. So that is pretty fast. There are aircraft that will travel at Mach 5. I don't know off the top of my head. I don't know top speed, but that is possible. So down here, I have another picture just for us to talk about again. It's just kind of settling into your heads. So at some point in time, the aircraft was right here. Sound traveled this far to the edge of the cone, right? The plane traveled this far, so wherever it is right now, the tip of the cone. So you're going to take distance plane divided by distance sound and you can figure out how many times faster than sound the plane that made that particular shock wave is going. The narrower the cone, the faster the plane. The more narrow the cone, but I'm going to write it this way. The narrower the cone, the faster the plane. The narrower the cone, the faster the plane, okay? What did I want to say? That's it. I want to tell you, do I have another thing? I do. So here is another one of these, but you'll notice I didn't put the other line in, showing you the other half, like, of this cone. So that's because I wanted this to be really clear. I want to show you this thing here. We call this the half angle. So that is the half angle, and this is a half angle of maybe like 25 degrees, I would say, looking at this. So if I took my protractor and I measured this angle, it would probably be about 25 degrees. So that is the half angle. If I'm going to show you the whole cone, of course I would show you the whole cone. So there is the path that the plane is flying on. There's the top of the cone. I don't have to just do that. I can do like this. I can put my circle in. Start in the middle. No. There we go. And then I can make sure my cone is correct. So you could take, if you just had this half angle given to you, or you could draw a half angle with your protractor. You could take and put in a circle. You're like, well, the middle has to be there. So you could take something circular, like a quarter or a nickel or something. It's not a good circle. You could take something circular that you have available to you. It doesn't matter where you make it because the radius of the circle, you just adjust. All right. And then you could draw in the whole cone. And then you could figure out, based on the half angle, how quickly this plane is moving relative to this speed of sound. And that is it for chapter 19.